Recording in progress.
Hey everyone, Mahith and Daniel. We're just gonna wait for everyone else to join and then we'll begin very soon. Hey everyone, can I just get someone in the chat to let me know if you guys can hear me? Is the audio coming through fine? Can you guys hear me? Thumbs up, or just let me know in the chat or you guys can unmute. Just let me know if you guys can hear me.
Yep, I can hear you.
Yep, perfect. All right, we'll just wait another 5-ish minutes. Few more people should be joining. While we're waiting, you guys, if you could just on the chat, let me know what school you're from. I'm assuming most of you guys should be in year 12. If not, you can say you're in year 11, doesn't really matter. Just let me know what school you're from. Your names I already have, which is a brief introduction. Yep, Canleyville High School, excellent. Year 11, okay. Yeah, year 11, the content today may seem difficult because year 12, year 11 does have a pretty big jump. Um, as long as you know, like if you're currently in mod 3 at school, some of this will make sense. For example, say when we do our trust analysis questions today, that's the same as like concurrent force questions that you would have done in mod 1, mod 2. A lot of moments questions, so that's again mod 1, mod 2. But yeah, good that you're here. I think this good practice for next year when you actually are doing your year 12. But nice. All right. Give another few minutes and then we'll begin. All right. We can just begin and then other people can join later. Wonderful. All right. So welcome to the Year 12 Engineering Studies webinar. Rough structure, it will be about 90 minutes probably to go through the exam. Could be a bit earlier, could be a bit later, depending on how we go through the exam itself. There'll be an end session ideally for 30 minutes. Again, it varies depending on how quickly we can get the exam done. In the Q&A, you guys can ask any questions that you might have. I know you guys put in some questions on the forum itself. I'll be going through those at the end of the exam. Any questions you might have, whether it's like about us, etc., tutoring, how to prepare for trials, because trials are coming up pretty soon in a few weeks' time. If you're interested in past papers, any questions at all, you guys can ask me that either on the chat, you guys can like say it out loud, either is completely fine. But that's like a opportunity for you guys to kind of ask any questions you might have. Wonderful. So yeah, a bit about me. My name is Armaan. I'm a fourth year studying aerospace engineering at UNSW at the moment. I'm in my final year, so I'm pretty close to graduating. I did my HSC in 2022 from Sydney Boys, and I did engineering studies when I was in high school as well. I've been in your shoes. I know engineering studies can be quite a daunting subject, but in my opinion, if you apply yourself in the correct way, it's actually very easy. And the biggest thing is, it's probably, in my opinion, the easiest subject out of like the sciences or like maths to get marks relatively easily. In my opinion, the markers are very lenient. So if, as long as you're not writing anything stupid or doing anything stupid, you will be rewarded for your marks, and that's how you can get high marks in your trials and stuff altogether. Wonderful. All right. Any questions before we begin? Chuck it through in the chat. I'll be checking the chat throughout the entire time. Otherwise, in terms of the exam, it's 72 marks. I've split it up into a multiple choice section and then one key short answer section for the first three modules. I have not put in mod 4, which is telecommunications. Some of you may have already started going through telecommunications at school, which is fine, but most or majority of schools across the state don't usually cover telecommunications. If anything, they go through the first dot point, which is just the basics of historical and societal influence. Um, which is fine. Realistically, your trials wouldn't have telecommunications in it. If it does, it's just on that first part. That's why I haven't put it in to this exam itself. Of course, the only difference from this paper to what your trial paper would be is that they might ask questions about that. Otherwise, no real difference. Excellent. All right, so let us get started with the exam then. All right. Um, the exam, I would like you guys to unmute yourself at times to answer questions. I want us to do this together, not me doing it the entire time. So we'll get started with the multiple choice. Take like 2, 3 minute break, and then go through the short answer section together. Alrighty. This first question, it's from a previous HSC paper. It says, which row of the table correctly identifies the materials represented by the microstructure shown in the top row of the table? So as you guys can see, we have 4 different microstructures shown. We want to select which option is the correct answer and correctly represents this. So anyone want to unmute themselves or in the chat, let me know what they think the answer might be. I can explain it as well and go through the answer myself. Anyone have any thoughts? Put in the chat.
Is it B?
B? B or D? Was that on?
B.
Sorry, can you repeat the answer?
B.
B? Why do you think it's B?
Because the first structure shows the ferrite, the high carbon steel, and the other one has perlite and graphite flakes for gray cast iron.
Mm-hmm.
And the third one just shows pure perlite.
Yeah.
And the fourth one is cementite.
Yep. So the first one is a mixture of perlite and ferrite, which is often the most common type of microstructure you guys would be drawing in your exam. The second one, the biggest thing to note for the second one is the fact that we have graphite flakes. Um, that's a key thing we want to pay attention to is the fact that we have the graphite flakes. The second one is almost completely perlite. And the last one, as you identified, the Fe3C, that's just cementite with the perlite itself. Now, the easiest way to figure out what our answer is here, in my opinion, for multiple choice, usually you can just like go through it and then eliminate it because most of the time, most of the answers are just blatantly wrong, and then there'll be one or two that are pretty close. The answer for this one is D. The best way to figure this out, as I said, this first diagram is the one that you will most commonly be analyzing, and NASA typically mainly makes us analyze mild carbon steels. So that's in like the range of 0.1 to like 0.5% carbon. It's relatively in the medium to lower end, actually. But that's our mild carbon steel. The way we can tell that this is gray cast iron has graphite dissolved into the grain itself. So that's how we can identify the fact that this is gray cast iron over here. When a microstructure is almost completely perlite, it is because of the fact that it is overwhelmed by a high carbon percentage, hence it is a high carbon steel. And then finally, white cast iron. The white name comes from the fact that it has cementite in the grain structure itself, hence the diagram looks like a white diagram, hence why it's called white cast iron. So for the first one, simply just D. Perfect. Next one. Which property is necessary in the manufacturing of a sheet steel car door panel? So, what do we think the answer would be for this? So, again, as I said, for multiple choice questions, majority of the time, just process of elimination, cancel things out. So, automatically, corrosion resistance should not be something that's coming to your mind at all when you're looking at this. That's not really something we care about for this exact property itself. So from A, B, and C, anyone want to chuck in the chat or say what they think the answer might be?
A.
A, fatigue. Why do you think it's fatigue?
uh, so it can like endure loads over time
Yeah,
without
yeah,
deforming.
yeah. So fatigue resistance would definitely be a property you would want the door panel to have. Obviously, if you're like driving a car, you're going to be opening the door, like opening and closing the door constantly. It will also be like with during a lot of loads. In this question itself, the trick is the fact that it's talking mainly from a manufacturing point of view. So when you are manufacturing the door, what property do we care the steel to have in order to make manufacturing easy? Now, if we were manufacturing this, typically it would be casted, or you can use any other manufacturing process as well. But the property that would be the best suited for this manufacturing process is ductility. Ductility, the more suitable answer technically should be the malleability part, but they both kind of go hand in hand. If something is ductile, it's also going to be malleable. But in this case, the property that would best assure the manufacturing of this car door would be relatively easy and smooth sailing is the property of ductility. And steel is a relatively ductile material. Perfect. Question 3, as you guys can see, this is like civil, relatively straightforward question. A simply supported beam with a vertical point load is shown. Which row of the table correctly describes the shear force and the bending moment diagram at point A? So we want to figure out in the shear force and bending moment diagram, at point A is going to be minimum maximum, and then for bending maximum, minimum, same thing. The best way to do this is simply just draw a rough diagram. So if we were to analyze this, there would be reaction force at point A. Let's just call that point A. Reaction force at point B. For shear force diagrams, just draw literally parallel going straight down and across. Now, realistically, it would be RA going up. You go across some amount, go down by A, go across, go back up to 0. Key thing is for shear force diagrams, and bending moment diagrams as well, we always start and finish at 0. Now, looking at this at point A, what we can see is the fact that, is this the minimum or maximum point at point A? So if we look at this diagram, we go up by RA with whatever that vertical support was. We go across, the force A is applied. We go down, go across, and then the reaction force at point B. So this is our minimum point for our shear force diagram. Now, for bending moment, same sort of thing. Go down, go across, draw your diagram really quickly. Bending moment, if anyone doesn't know, it's simply calculate the area of this square. So let's just call this area 1, area 2. And then we will literally go up by area 1, and then area 2 should just be the same magnitude, but just negative, and then we finish at 0 again. So at point A, this is now the maximum bending moment. So then we go down to our table, min max, so it's just option A. Perfect. Any questions? Keep chucking them into the chat. Yes, probably minimum shear force. Excellent. All right. Question 4. This is a very standard type of question that you guys will be asked. NESA, or even in your trials, you will get at least one question on true length. Most likely going to be a multiple choice. They don't really like wasting time as a short answer question itself. In this question, it's simply asking the orthographic views of a part are shown. What is the total number of true lengths that are visible in all 3 views? So firstly, this is a third angle projection. We have our top view, front view, and side view. Now, for true length, the questions can vary. It can either be an orthogonic projection where you have all 3 views, or typically it's just top view and front view that are given in true length questions. It's very rare to see a side view as well, but it varies depending on what question is asked. Now, can anyone tell me what are the typical rules for us to determine if a line is true length or not? What are the typical rules that we follow? Does anyone know? Chuck it into the chat. If not, I can go through them. Anyone want to give a guess? Wayne, maybe. Yeah, so this is mainly applying for top view and front view. We have 3 primary rules that you want to follow. The first is if a line in top view or front view is parallel to our plane, we just draw a straight horizontal line going across just in between top view and front view, is parallel in both, it is true length. That's the first one. So if it's parallel in both, it will be true length. So if we just look at this as an example, this line over here and this line over here are parallel in both. So that is true length. Same would go for this. That line and this line are also the exact same. So that is also true length. So we can mark a 2 over there. The next point, if a line is parallel in one view, but not in other, the other is the true length. So again, this line over here represents these 2 diagonals. It's parallel here to the plane, so it is true length over there. Next rule. If a line is a point in one view, it is true length in the other. If we look at this line over here, that's represented by just a singular point. So this is also true length. Same with these two lines. They're represented by just a singular point over here. So they are also true length. So all of these outer edges in the top view are all drawn to true length. Now, the side view has also something where we can determine if it's true length or not. Does anyone want to guess or tell me how we can determine with the side view if a line is true length or not? Similar rules will be applying. Anyone want to guess? Even then, there's another line that hopefully you guys can identify is this vertical line over here is a singular point in the top view. So this is also true length. So right now we have 8. In the options, 8 is obviously not an option. So we want to figure out if we can find at least one more. If we can find 2 more, 3 more, 4 more, then that's how the answer will vary. So we have 8 right now. Can someone tell me how many more true lengths we have? Anyone want to guess? You can unmute yourself to explain, or you can write in the chat. Either is fine. Anyone want to tell me? Nine? Where is the 9th one? Where would the 9th one be? If there is 9. I'm not saying necessarily that's correct, but where would it be? On the side view toward the right of the side view? These two? Yeah, you're actually correct. These two are our 9 and 10 true length. Now, can someone tell me why these are our true length values? Does anyone know? So as I said earlier, these rules applied typically is just applied for top view and front view. For the side view, we also have rules that are applicable. Oh, notification. So 9 and 10 are also applicable in the same way. Diagonal in 1, parallel to this plane now. So for side view, we draw a similar plane, but this time it's a vertical plane instead of a horizontal plane. Same thing would apply. It's exact same thing. So if it's parallel in one, not parallel in the other, it is then true length in the other one. So in this case, it's just 10 as our true length. So typically, we just have top view and front view. So these 3 rules are the main what you need to do. Just draw a horizontal plane in between the top view and front view. If you're given an orthogonal projection, just draw another vertical plane in between. Same rules apply even for that one. Perfect. All right, this question, I hope no one struggles with. This is the easiest free mark in my opinion. We have a stress strain graph shown and it has a 0.2% offset from the origin. What material property can be calculated by using the dotted line shown? What is our answer for this? Does anyone want to tell me? Write in the chat, unmute yourself. Either's fine. Does anyone want to tell me?
C.
Yep, proof stress. Excellent. So proof stress, as the diagram shows, you're given your 0.2% offset. You draw a parallel line to where it's linear, so where the Hooke's law is being applied. You draw a parallel line, keep going up until you intersect with the curve itself, then go completely horizontal. This is your proof stress value. Perfect. Next, we have a load extension diagram. Load extension, stress strain, they're pretty much the exact same thing. Of a mild steel specimen. The question's asking at what region do we have permanent change in shape and size? That should just be in this region over here. So point C is our yield point. So it's the maximum amount of load that this mild steel specimen can take before it starts to begin to permanently deform. So after this point, there's no coming back. You're going to have permanent deformation on your specimen itself. Now, can someone tell me what this point over here is called? And I will say one thing is that this is a load extension graph. So there is a difference in terms of the name. So what is this point called? Tell me the abbreviation, tell me the full name. You can chuck it into the chat or say it, like unmute yourself and say it out loud. But what is that point called? So the highest point on a stress strain or a load extension graph for a steel specimen. What is that point called? Anyone know? It starts with a U. That's something I will say. So what is that point? UTS is a good guess. So as I said earlier, because this is a load extension graph, it's called a UTL. So this is the ultimate tensile load because of the fact that it's a load extension graph. If this was a stress strain graph, then it's called the ultimate tensile stress. So then it's the UTS instead. Perfect. So yeah, as we said, just option D. Question 7, why did steel replace cast iron in bridges built after 1850? So cast iron was the first material that was used when building bridges in the early Industrial Revolution. The reason why it was replaced was because of the fact that its tensile strength was not fantastic. It was good at compressive loading, but its tensile strength wasn't great. It was also relatively quite brittle. That's why it was replaced. But for this, it's purely because of the fact that its tensile strength is quite poor. So hence steel replaced it in the construction of bridges in the 1850s. Excellent. Question 8. Which of the following cause fatigue cracking in a metal? Does anyone want to tell me what the answer for question 8 will be? D? Excellent. Cyclic loading. So cyclic loading is essentially where we're applying a load, removing it, applying a load, removing it, and it's constantly being in that cycle. That's why it's called cyclic loading. It's a big issue that happens to metal. That's why when you're actually manufacturing something, you need to select a material that has higher fatigue resistance. This is more so something that is applicable for mod 7, so aeronautical. Aircrafts go through a lot of cyclic loading, so fatigue resistance is a big thing for material choice. That's why we have those aluminum alloys that are used for the aircraft itself. So question 8, D is that answer. Perfect. Question 9. Now, this is not exactly a friction question. It's more a work energy question. So in this case, we have an inclined plane that's 5 meters long and 2 meters high. A force of 50 newtons is required to push a box along the length of the slope. Assume no friction, so hence why it's not a friction question, and 100% efficiency. What is the mass of the box to the nearest kilogram? So this is simply just a work energy question. So in this case, it's just force times length of the ram is equal to the weight times the height that you take the box up. So this is a simple machines question. So in this case, we substitute our values in. Our force is 50 newtons. Our length is 5 meters. Weight we can break down into mass times gravity, which is 10 in engineering studies, times the height, which is 2. Therefore, 250 is equal to 20 times m, or our mass. Therefore, mass is just 250 divided by 20. That gives us 12.5. Estimate that to 13. That's our answer. Excellent. Question 10. Why are gap joints strategically placed in pedestrian footpaths? This is kind of an off-syllabus type of question. It's not really something you would expect. C? Why is it C for question 10? You're correct. You are correct. It is question C. Do you want to tell me why it is C there? Exactly. Expands in heat. So in civil construction, a big thing you want to account for is the fact that materials expand and contract depending on temperature. So you want to account for that by adding in those small gaps so that if it does expand, it's not exactly going to start cracking because of the fact that there's no space for the concrete to expand in. So that's where we have those gap joints in between the footpath itself. Excellent. Question 11, this is just our basics in terms of our flight mechanics from Mod 7. As you can see, we have an airfoil, we have airflow going this way, lift is going up. We have pressure 1 and pressure 2. Which condition needs to be achieved for lift to occur? What would our answer be for this one? So obviously we want, yeah, A, exactly. So simple thing from Bernoulli's principle, when pressure is low, velocity is high. Pressure is low, velocity is low, pressure is high. We have a difference in pressure that is net positive up. Therefore, that's how we generate our lift. So in this case, our answer is just A. Perfect. So following that, we have our Venturi effect system shown over here. What does the diagram illustrate? It's a Venturi system is just used to represent Bernoulli's principle. Excellent. Question 13. In the process of manufacturing a concrete slab, cables are placed in ducting. After the concrete is poured and cured, the cables are stretched, anchored, and released. What type of concrete slab is this? Post? Excellent. The way we can tell it is post is that it says after curing has occurred, that's when the tensile stretching has been done. So excellent, post tension. Wonderful. Question 14. What is the correct angle of repose for a rock field used on a highway construction? Excellent. C. We know coefficient of static friction is just frictional force over normal. For angle of repose scenarios, it's also just tan theta. Therefore, our theta, so our angle is just tan inverse 0.84, and that's just 40 degrees. Wonderful. Question 15. Which propulsion system requires fuel and an oxidizer, such as liquid oxygen? Yep, a rocket. Excellent. The rest of these just require airflow going in. A rocket engine, obviously, a rocket is flying in space where there is no oxygen, so we need an oxidizer such as liquid oxygen to be carried on board to actually react with the fuel itself. The rest of them are within Earth's atmosphere, so you don't need an oxygen tank with it as well. 16. Which of the following statements correctly describes Hooke's law? What would our answer be for this? C. Excellent. Force induced in an object by stretching it is initially proportional to its extension. So that goes all the way back to our load extension graph over here. This is where Hooke's law is applied. Simply, it's just load is related to the extension of our specimen itself. Wonderful. Question 17. Which statement best describes the difference between cast iron and steel? So this is quite similar to that previous question about the bridges. What would our answer be for this? D. Excellent. Cast iron has a higher percentage of carbon. Wonderful. That's why it's called. Cast iron is also flaky. It's also brittle. That comes from the fact that it has a higher carbon percentage. Steel obviously has less. That's why it's also better in tensile resistance. Wonderful. All right, we're smashing through these. Question 18. A crane lifts a 2400 concrete panel to a height of 8.5 meters. What is the minimum work done by our crane? Now, a key thing to note for this question is the fact that it says use gravity as 9.8. Obviously, your teachers would have taught you this. You would have done this at school yourself to assume that gravity is 10. Whenever the question specifically says the gravity value, please use that. Yep, everyone's saying B. Excellent. So work is just mass times gravity times height. So we said 2400 times 9.8 times 8.5, and that should give us simply option B. 19. In the process of manufacturing concrete slabs, so this is very similar to question 13. Our concrete is poured and cured. The cables are stretched and anchored and released, but before it's poured, the stretching has been done. So if it's this tensile load is applied before curing is done or the concrete is poured, excellent, pre-tensioned. Now, can someone either in the chat or unmute themselves and tell me why is there a difference between pre-tensioned and post-tensioned concrete? What's the difference? So obviously they both have tension being applied, but why might you do one over the other? What is the difference in between the two of them? Does anyone know? So going back to mod 5, when you're looking at pre-tension versus post-tension concrete, why is it that you do have two different variants? Yep, excellent. Omega, perfect. One's done on site itself, the other one is done in the factory. So that is correct. Which one is done on site and which one is done in the factory? Can you tell me which one's which? So pre-tensioned, where is it done? Pre-factory, post. Yep, perfect. Wonderful. The reason being is because concrete takes a long time to cure, and obviously if you're on site itself, you don't have all day to be waiting for the concrete to cure. So you already have the concrete with the ducts and it fully cured. You just chuck the cable in, apply the tensile load, hence post is done on site. Pre-factory, you have the time, you're not in a rush or anything, so you can take your time, hence do pre-tension instead. Excellent. Final multiple choice question. An aluminum alloy aircraft undergoes solution heat treatment followed by artificial aging. Which of the following best explains why yield strength increases during the aging stage? So this is a part of the Mod 7 topic in terms of looking at materials. We're looking at precipitation hardening here. Precipitation hardening involves firstly solution heat treatment and then aging. C, excellent, Josephina. That is correct. By this, why the yield strength increases. By aging it, we essentially allow more precipitate particles to form throughout the mixture, more precipitates that form naturally, more preventing more dislocations. So obviously the yield strength of the material will increase altogether. Fantastic. All right, so that is it for the multiple choice. Hopefully everything made sense. No questions with that whatsoever. Since we did that quick, we can jump straight into our short answer section. If you guys want to go, actually, I'll give you guys all a 1 minute break. If you want to go to the toilet real quick, go ahead. We'll resume back in about 1 minute's time. In the meantime, you guys can chuck in any questions you might have about the multiple choice. Otherwise, in a minute's time, we'll start with the short answer. All right, let's get started. This, it should say mod 5, not mod 1. Civil structures, truss analysis, 100% expect to get a truss question in your trials and definitely in your HSC. So over here, we have a truss. Part A simply says to determine the vertical reactions at supports A and E. First thing, before we even go into that, we have a diagonal load being applied at point C over here. First thing we can do is break it down into its vertical and horizontal components. So we have 20 cos 30 going to the left, and then 20 sine 30 going down. Now we want to find the reaction forces at these 2 points. At point A, we're going to have a vertical and a horizontal. Why? Is because it's a fixed support. Roller support just has a vertical, so that's just acting straight up. RE, we don't have to say V or anything. We can keep it as it is. Now we can go into finding we just care about the vertical reactions for the time being at supports A and E. So to do this, we use our 3 fundamental equations. Sum of forces in the vertical is equal to 0. We say up as positive. Always just write this in just so the marker knows what you're defining as your positive. We have RAV plus RE both going up. Everything else is going down. 45 plus 45 plus 20 sine 30. That gives us a total of 100 kilonewtons in this case. We can do the horizontal as well, just because, like, why not? Right is positive. RAH is the only other horizontal force. That's just equal to 20 cos 30. Just do it. Why not? 17.32 kilonewtons. Now, I have 2 unknowns, and how would I figure out? What's the next step? So I have 2 unknowns. So what's my next step to figure out what RAV is and what RE is? What should I do? What is the next step here? Anyone know? Yep. Some moments are at point A. Excellent. We do it around point. We always typically do it around the fixed point. purely because it then eliminates the horizontal force. We don't have to deal with it. Just stick to the habit of doing it around your fixed support. Sum of moments about point A is equal to 0, defined clockwise as positive. Now, something I would recommend to do is you can put all your force distance on one side and say equal to 0. Me personally, when I was doing my HSC, I preferred putting all the clockwise rotational forces on one side and anti-clockwise on the other. So something you can do is just draw a rough diagram. So if we look at this point, this load over here is going to go clockwise. That's also clockwise. This is anti-clockwise. This is clockwise. Now, this 20 cos 30, will it go clockwise or anti-clockwise? Does anyone know? Clockwise or anti-clockwise? What are we thinking? So imagine this entire system, and I'm applying this load. It's going to try going up. So that's also considered an anti-clockwise. Yep, excellent, anti. So then put all the antis on one side, clockwise on the other. We want to know what our distances are as well. The entire thing is 15. That's 7.5. So half of 7.5, 3.75, 3.75, 3.75. This question is also designed to be slightly difficult because of the fact that we need to figure out what. If it's at 30 degrees, is it acting through A? Um, Technically, yes, the 20 kilonewtons is acting through that point since it's at 30 degrees. But since we've broken it down into vertical and horizontal, we will include it. If I didn't break it down into vertical and horizontal, then technically I don't need to since we're taking moments about A, so it technically lies in the point, so that is correct. But since I've broken it down into 20 sine 30 and 20 cos 30, I now am including it, but maybe it might cancel out because of the fact that it is still in line, so we can figure that out. Um, very quickly, let's find our height of this truss. How would I find this distance? Can someone tell me? How would we find that? Should just be basic trigonometry. So say that's 30 degrees, that's 7.5. How do I find height? What trig function? Tan, excellent. So we say tan 30. It's h over 7.5. Therefore, h is just 7.5 tan 30. Now we have everything we really need. Let's start with the closest force, 45. So 45 times 3.75 plus 20 sine 30 times 7.5 plus 45 times 3.75 plus 7.5. That is correct. So let me just double check. Yep, 11.25. Any other clockwise? Nope, just those three is equal to RE times 15 plus R20 cos 30 times the height, which was 7.5 tan 30. So now simply just take this to the other side, divided by 15. So let's do that. This will be a long input on our calculator. 20 sine 30. Realistically, in the exam, show more lines. I'm just going to put it all into my calculator and see what we get as our answer. Minus 20 cos 30 times 7.5 tan. So we get our RE as 44.85 kilonewtons going up. Sub this back into here. Therefore, RA is 100 minus 44.85. And that gives us 55.15 kilonewtons also going up. So that's part A done. We've determined our vertical reactions that supports A and E. Part B, we are now doing method of joints at point A. We want to calculate the force in members AF and AB. and state whether they are in tension or compression. So we want to figure out the forces in this member and that member. Simply all we do is we analyze point A. So I draw my point A. I have RAV, which we figured out to be 55.15 kilonewtons. I have my RAH, which is just 20 cos 30. That's 17.32 kilonewtons. I then have my force AB, force AF. That's 30 degrees. Always just assume that it's in tension, so draw the arrows going away from the point. Obviously, if the answer is negative, that means it's in compression, then you can draw it the other way around. So to do this, this is just a concurrent force question, so year 11, mod 1, mod 2. To do this, first step is break our force AB into its two vertical and horizontal components. So let's do that. Force AB, sine 30, and then force AB, cos 30. Wonderful. Now, same thing. We take sum of forces in vertical, sum of forces in horizontal. Vertical is equal to 0, so we get force up is positive, force AB sine 30 plus 55.15 is equal to 0. This automatically tells us that AB is probably going to be a negative value, so it's in compression. That's fine. Let's take it. Let's look at this. No other forces. Wonderful. So then force AB is equal to negative 55.15 divided by sine 30. That gives us 110.3 kilonewtons in compression. It's in compression because of the fact that we assumed it's in tension by going away. It gave us a negative value, so therefore it's in compression. Wonderful. Now, for force AF, same thing. Sum of forces in horizontal is equal to 0. We say right is positive. We get 17.32 plus force AF plus force AB cos 30 is equal to 0. We already know what AB is, so we can take everything over to the other side except for the force AF. AF is equal to negative 17.32 minus force AB cos 30. Now, key thing is when you do substitute in your value for AB, do not do positive, stick to the negative because we are still assuming based off the diagram that it's in tension, so it has to be a negative value there. So therefore, we get negative 17.32 minus negative 110.3 cos 30. Plug it into a calculator. 17.32 plus 110.3 cos 30 should give you a positive value, 78.2 kilonewtons. Hence, that is in tension. Fantastic. Any questions at all, please do chuck it into the Zoom chat as we are progressing through it. Wonderful. All right. Let's hop straight on to the next question. Now we're doing method of sections, which is the other way to figure out forces of a member. To find the force in member FD, say whether the member is in tension or in compression. So looking at this diagram, we want to find it in member FD. That's this member over here. Now, key thing with method of sections, as we know, is we can only cut through a maximum of 3 members. So I can't exactly do that because that's way more than 3 members. So naturally, I would just cut straight through like this. Now, can someone tell me which side we should take our section and why? Does anyone know? Should I take the section of the left-hand side or the right-hand side? Which one should we take? Right, excellent. Why would we take the right-hand side? It's a pretty straightforward answer. Simple thing is, when you do make your section, just count how many forces. Yeah, exactly. Less forces to calculate. Simply just calculate how many forces are there on either side. So if we look at the left, we have 1, 2, 3, 4, 5 on the left-hand side. On the right-hand side, we just have 1 and 2. So significantly less forces. It makes your life a lot easier. Just no, the cuts cannot be curved. That's a good question. It has to be directly straight. So you can't exactly make a curve to include like an extra force or something. Simply just make it directly straight. The curve really won't make much of a difference because you can't exactly like break to an extra member. Just keep it straight, the cuts the entire time. So yeah, we're going to be analyzing the right-hand side. So naturally, step one is, okay, we are taking the right-hand side. So let's draw the free body diagram for it. So we have point D, point E. Our cut is made through here. We have force CD going that way. Force DF or FD going that way. And then force EF going this way. That is 30 degrees. We have an external load of 45 kilonewtons acting at this point. And then we have our RE support, which we calculated to be 44.85 going up that way. So now what is the next step over here? And that's 30 degrees. So this going up that way. Excellent. So now what is the next step here? We want to find the force in member FD over here. So what should we do? So naturally, when we make a section, you will have one that you care about, and then you have two unknowns that you do not care about. So in this case, force EF and force CD, we do not care about. We want to ignore it. Like we couldn't care about it at all. So what should we do? Should we take moments? Should we do sum of forces? What do we do? Does anyone know? What can we do? So we would take moments. Where do we take moments about? So we don't care about force in EF and CD, so we want to eliminate them. So we take moments about point E, since they both lie at that point. So we would take moments about point E equals 0, clockwise as positive. So naturally now, if I look at my diagram, this force gets eliminated because it's on that point. That force gets eliminated, that force gets eliminated. The only one that's left is my FD and my 45 external load that's being applied as well. Now, all we do, force, perpendicular distance, force, perpendicular distance. I know this distance for the 45 is just 3.75, since the entirety of it is 7.5, so that should just be 3.75. Now, we want to figure out what my perpendicular distance for my FD is. There are two ways to solve this. Method one is draw a imaginary line that continues on from this and then go straight down. That's my perpendicular distance. Why can we do this is because forces can be put anywhere. So say, for example, this was my force. I can make it go anywhere as long as it's in the same direction. So we can either find this distance and then plug it into there. Yep, line of action, excellent. So we can either find that distance, or the alternative method is simply break my force FD into cos and sine components and then do it that way. Like either is completely fine. They should both give you the exact same answer. So let's try finding the perpendicular distance. That should be relatively straightforward. To find the perpendicular distance, it's simply just trig. I have a triangle like so. That's 30 degrees. I know my base length is just 3.75. So my perpendicular distance is just, let's just double check this. Sorry, it's 7.5, not 3.75. Yep, 7.5. And we care about height. Again, h is just 7.5 tan 30. That just gives us 4.33 as our height. So now we know what our distance is. So now we're ready to go. This is going anti-clockwise. That's also going anti-clockwise. So they'll be together in our moments equation. So we get 45 times 3.75 is equal to plus force FD times 4.33 is equal to 0. Therefore, force FD is equal to negative 45 times 3 over 4.33. That gives us negative 31.18. Sorry, I have not done that correct. 38, sorry, negative 38.97 kilonewtons, therefore 38.97 kilonewtons in compression. So that's how we would do it. Now, a key thing to know for method of sections, this is a key rule to follow. For unknowns. And when I say unknowns, I mean these three like forces that we've determined because we've made a cut. If unknowns are in same direction, so they are parallel, take sum of forces in opposite direction. So what that means is, in this case, essentially, if let's say I had to find like if my unknowns were in the same direction, so they were both going horizontally across or both going up, just take sum of forces in the other because you can't take moments since there's no point where they will lie at the same line. And then the other is simply if one unknown is diagonal, so simply if not parallel, take moments at point of intersection. So that's what we've done. Excellent. So that is essentially it for this truss question. Realistically, you won't be asked a method of joints and a method of sections. They typically just ask one or the other. But even if they do, relatively straightforward. Perfect. Next question is now one on beams, or this is our shear force and bending moment question coming in. So as you can see, we have a standard beam shown. It's an I-beam, 6 meters in length. We have two loads, 20 kilonewtons and 7 kilonewtons applied at certain points. First step is to calculate our redundant members aren't typically. Sometimes they do, just as a trick question. They'll ask you to find the force in nature, and then when you calculate it, you'll figure out that, oh, it's 0. And sometimes students are left confused. That is sometimes a trick question they like to add in. It's very rare, though, in my opinion. If anything, they might just ask a multiple choice that says, what are redundant members, or why are they added in? Yep, for this one, excellent. So sum of force in vertical is equal to 0, up is positive, RA plus RB is equal to 20 times 2 plus 7 times 3. That gives us 61. We then take moments, excellent. Take moments about either point A or B, doesn't really matter. Clockwise is positive. We get 20 times 2 plus 7 times 3 is equal to RB times 6. Therefore, RB is 20 times 2 plus 7 times 3 divided by 6, 10.17. Therefore, RA is 61 minus 10.17, so 50.83 kilonewtons. Wonderful. Now, next step is steel I-beams have been used when large open spans needed to be created. So this is a theory question. Explain how microstructural changes take place in steel when an I-beam is formed using the process of hot rolling. So how might we answer this? So it's a 3 marker. So realistically for this question, first step is explaining very briefly what the process of hot rolling is. The second part is explain what changes does it make. And that is kind of broken down into 2 extra marks. So how might we, or does someone want to type into the chat or unmute themselves and say, what would the answer for this question be? So it's asking us to explain how the microstructural changes take place in steel when an I-beam is formed using the process of hot rolling. Anyone want to try answering that question? All right. We have a response. Josephina, excellent. All right, let's have a read of this. When steel is hot rolled, it is heated above its recrystallization temperature. Fantastic. Where its microstructure becomes softer and more workable. As the roller compresses to shape the steel into an I-beam, the existing grains become steels. Fantastic. That is a perfect response. Like 3 out of 3, 100% for the response. The best thing that Josephina's done there, she's firstly explained what hot rolling is by mentioning key technical terms like recrystallization temperature, the fact that it becomes soft and more workable. She's also explained what happens to the grains itself. And the final thing she's done is that she's also explained what end mechanical properties you get. So saying that the steel's strength is improved, toughness is improved, and ductility. So that is a perfect 3 out of 3 response. Fantastic. All right. I will put a copy of that into the solutions later. So fantastic, Josephina. Wonderful. So now we can move on to our mechanics question again. So now we're looking at our shear force and bending moment diagrams. So good thing is we just take what we had from here, plug it down. So we have 50.83. So that is our 50.83. The other one was 10.17. Now, I don't think I made these diagrams to scale, but that's fine. Ignore the scale on the side. Let's just draw a horizontal line going across. I'm going to draw it not to scale, not the biggest issue over here. We're going up by 50.83. We go across 2 meters, 50.83. We go down by 20, go across. This is 30.83. Hold on. Have we done that correct? Okay, why is this significantly high? Let's double check this really quick. Yeah, I understand why that is done wrong. That's just 20 plus 7, 27. 27 minus 10.17. 16.83. All right, that makes more sense. Fantastic. Yeah, 16.83, 10.17. Wonderful. So yeah, now the diagram is more to scale. 16.83, we go up, go across, go down by 20. So 16.83 minus 20 is 3.17, or negative 3.17, so that's about there. Go across, negative 3.17, go down by 7 again. So now we're at 10.17. All the way across, back up to 0. So this is our negative 10.17. So now shear force is done. Obviously, this is not to scale in your actual exam. Make sure it's directly to scale with your units. Next up is finding out area. Very straightforward, 16.83. We multiply this by 2 because it's 2 meters. 16.83 times 2 gives us 33.66 as that area. Break this off as well. We get negative 3.17 times 1. So that's just negative 3.17. Final one, negative 10.17 times 3 meters. That gives us negative 10.17 times 3. That gives us negative 30.51. So now we have all of our areas, so we just apply it. First one, 33.66. Again, I'm drawing this not to scale. So realistically, will just be directly down. So let's just try sticking to that. Wonderful. All right. We have 33.67 or 66. We then go 33.66 minus 3.17. That gives us 30.49. So we go across. We say that's 30.49. Now, just because of rounding, it's not exactly going to be back to 0, but we just say, okay, don't worry too much about it. It has to go back to 0. So this is now our bending moment diagram. Now, can someone tell me what our maximum bending moment is from this diagram? What is our maximum bending moment? I don't think I added that question in. Yeah, 33.66. So it's just the highest value. Now, a key thing to note is, say hypothetically, you had a bending moment diagram where you went up to, let's say, 25, and then you went down to -30 and then back to 0. In this, your maximum bending moment is not the 25, it's the 30. We don't care about if it's negative or positive, we just care about the magnitude itself. So it doesn't matter if it's positive or negative, it's just the magnitude that we are focused on. Fantastic. So again, this was not to scale. In your exam, please do make it to scale, but that's really all there is to shear force bending moment diagrams. If anything, I didn't add it in, but a bonus question would be calculate the bending stress. So for this, you would be given, obviously we know it's m times y over second moment of area. You will always be given the second moment area. In engineering studies, they don't ask you to calculate that. If you were studying engineering in university, you would then be calculating the second moment area as well. So simply for this, you would plug in 33.66. They'll give you a diagram of the I-beam itself. Obviously, Y is, let's say we had our I-beam like that. The center line through the I-beam is known as the neutral axis. Our Y is just the distance from the neutral axis to the top. That's all that it is. So then you will plug it in, find your bending stress. But again, I haven't added that in, so it's fine. Wonderful. That's it for civil structures. We're now moving on to personal public transport. This first question is just calculating the speed, so it's work energy topic. So over here, we have a bicycle, a bike with a rider rolls down a hill without braking from a standing start at point A. The combined weight of the bike and the rider is 80 kilograms. Calculate the speed of the rider at point B. Assume no wind resistance and 100%. Josephina's already well ahead. Fantastic. So, yep, that's exactly it. We would equate potential energy is equal to kinetic energy because it's 100% efficiency. There's no friction in this system. Realistically, there would be, but in our case, there's no friction. mgh is equal to half mv squared. Cancel the masses out. It doesn't even bother us. Our v is simply square root of 2gh. We take, the question does not say gravity is equal to 9.8, so just take it as 10. The height itself is 20, so it's square root of 400. That gives us 20 meters per second. That's it. So in this question, they do not tell us to take gravity as 9.8 or 9.81. So we always just assume 10. So that is all that we do. Masses cancel out. Equate for velocity. That's our velocity. Perfect. Part B. The bicycle above is made from an aluminium alloy. Identify and explain a manufacturing process to make the frame of the bicycle. Does someone want to explain how we might do that? Does anyone know? I'm assuming Josephine is already on top of it, so she might say an answer. But does anyone want to unmute themselves and just kind of have a discussion and explain what they think the manufacturing process for this would be? Anyone want to unmute? Discuss? That's fine. We can discuss it together. So first thing that, all right, fantastic. Okay, Josephine is already on top of this. Excellent. In hydroforming, Hollow aluminum alloy tubes are placed into a shape sealed at the end. High pressure fluid is then pumped into the tube, forcing it to take the exact shape of the mold. This allows complex frame shapes to be formed with smooth curves. Fantastic. While keeping the aluminum lightweight but strong. Excellent. After forming the individual tubes, cut to size and assembled into the frame, they are then joined using TIG welding. Fantastic. Which produces precise, high-quality welds by using a non-consumable tungsten electrode. That is far beyond what they would expect in as a response in the HSC or your trials. That is like a university level response. The fantastic thing that Josephina's added in is TIG welding. It's important you mention that specifically. Aluminium, unfortunately, is not a material that you can weld using other methods. It has to be specifically done through tungsten inert gas. So TIG welding is the process itself that has to be used. It's purely because aluminum as a material, its heating or melting point is a lot lower as compared to steel, which is usually welded. So because of that, other welding processes damage and actually deteriorate the properties of the aluminium itself. So as Josephina said, hydroforming, excellent. A simple thing you can say is you can just extrude the aluminium alloy into a hollow tube form itself. And then once you have the extruded tubes, you can cut it into the exact size you need and then do TIG welding, combine it into the frame shape, and then there's your bicycle. Fantastic, but excellent stuff, Josephina. That is like far beyond what they'd expect as a response. Fantastic. C. In the early 20th century, bicycles were made from mild steel. If the same frame was made by investment casting, identify and explain a suitable heat treatment process and why it would need to be done. So in this case, we're no longer looking at aluminium. So if we were, then precipitation hardening is the heat treatment process we would do there. In this case, we're looking at the 20th century bicycles, so that were made out of mild steel, and the manufacturing process specifically is investment casting. So we want to identify a heat treatment process and then explain why it's a suitable process to be done in the first place. So for this question, first mark is to just briefly explain what identify a heat treatment process and explain what it is, and then explain why it would be done. So in this case, you can say normalizing would be an excellent option over here. You can say normalizing is the choice. What is it? You heat it to its recrystallization temperature, so about 800 to 900 degrees Celsius. Soak to achieve a homogeneous structure, so you austenize the structure itself, and then you air cool it. So that's the difference between annealing and normalizing. Annealing, you cool it very slowly. Normalizing, we air cool it. Why is it done? It's above. It's above. So you're recrystallizing the structure itself. The only instances where you do it below is in tempering, so hardening slash tempering. In hardening, we again heat it above the recrystallization temperature. In tempering, we do it below because we're just trying to get rid of the stress to reduce the brittleness but maintain the hardness. But in all other heat treatment processes, we're always heating above recrystallization temperature to homogenize and austenize the structure. So kind of reform the structure altogether. That's what we're doing. But yeah, normalizing is the process we would do here. Briefly explain what the process is. That's like a sentence there. Explain why it's done. So you would say that it's done after investment casting because in all casting processes, a big issue is uneven cooling of the cast itself. So usually there are internal stresses built in. So normalizing will allow all internal stresses to be like removed. We then have a homogeneous structure, so there's even strength across the entire like bicycle frame itself. And then air cooling is just part of the process. But yeah, your end result, high strength, high wear resistance, high fatigue resistance as well. That's exactly what you want for a bicycle. But yeah, 3 marks, excellent. Fantastic. Any questions even if I'm going too fast, let me know. You guys have any questions at all, chuck it into the chat or unmute yourself. Feel free to ask me. Question 24, this is a hydraulics question. Pretty common to get this. If you're in year 11, I know you probably wouldn't have done a question like this yet. In year 12 and mod 6, hydraulics is a big part with simple machines. For this, it's just applying Pascal's principle that pressure is constant everywhere. So our fundamental formula, as we know, pressure is just force over area. Josephina's added in her response. I'll get to that in a second. Yeah, so we're applying Pascal's principle over here, simply that force and pressure is constant all throughout within this hydraulic system itself. Specifically, the formula we apply here is area 1 times distance 1 is area 2 times distance 2. Yep, 45, excellent. Simply all that we say is pi times 120 squared over 4 times the distance that x is what we would figure out is equal to pi times 360 squared over 4 times 5. Rearrange, calculate d1 as Mahit said. D1 is just 45 millimeters. Perfect. Key thing to note, if some of you have not seen this, yeah, year 11 braking systems, fantastic. So if you have not seen this way of calculating area, please do familiarize yourself with it. In engineering studies, they'll always give you diameters. They'll almost never give you the radius itself. Obviously, with the radius, we know it's just pi r squared. Get into the habit of just doing pi times diameter squared over 4. Yeah, is way better. Exactly. It's way better than pi r squared. You're saving like a few seconds there. I know that doesn't sound like a big thing, but just save yourself the hassle and just stick to this. If any of you guys are planning to study engineering in university, same thing applies there. You'll never be doing pi r squared. It's just a norm to be using pi times diameter squared over 4. Perfect. If the hydraulic cylinder shown has a rated capacity of 0.85 tons, the diameter of the cylinder piston, as we know, is 120 millimeters. What is the oil pressure in the cylinder at maximum rated capacity? Does anyone know how we would do this? Again, we're just applying Pascal's principle. P is equal to F over A. We know what our maximum capacity rating is. So force is just 0.85. It's in tons, so convert it times 1,000 times 10 to get it into newtons. We then get 0.85 times 1,000 times 10, 8,500 newtons. Area, pi times diameter squared over 4. So that's, convert it into meters though. So pi times 0.12 squared over 4. Squared over 4. That gives us 0.01131 meters squared. We have everything we need. 8,500 newtons over 0.01131 meters squared. Our final answer is simply just 751,547 pascals divided by 10 to the 6. Get a suitable unit. We get divided by 10 to the 3. We get 751 kPa. Like that's good enough. But yeah, that's simply what we do. Simple formula, pressure is equal to force over area. Calculate your force first. Area, pi times d squared over 4 should not be too difficult. Plug both of them in. Make sure it's in the correct SI units. When you have newtons and meters squared, you'll get your answer in pascals. And then just divide it by a suitable, like 10 to the 6, 10 to the 3, kilopascals, gigapascals, whatever you want to put it in. And then there's your answer. Perfect. Question part C. Again, theory question. Outline applications of simple machines in personal and public transport in the 20th to 21st century. In your answer, identify one example of a simple machine and explain its role and specific social impact. Now, Josephina, I am assuming you're already onto it and writing response. Fantastic. Otherwise, I'm going to break down how exactly to write and get the full marks for this question. So to get the full 4 marks, the first thing is identify a simple machine. Now, there are so many you can pick from, like endless amount that you can pick from. You can say a lever, pulley, screw, gear, inclined plane, wheel, axle, so many, a hydraulic system. Pick any, it does not matter, as long as you can firstly identify a specific simple machine. The key part with the selection of the simple machine, though, is you want to pick one that is directly related in personal public transport. So that is a key thing. Pick one that is directly related to that. Next part is obviously explaining the applications of it. So first explain what the system is itself, explain its specific social impact with some evidence or historical grounding to explain as well. So a bit of an example that you can say, wheel and axle. This obviously is used in bicycles. You can say it there. Or gear and chain is another one you can say. Bicycles is, yes, link it to one form of transport. That's exactly it. So identify your simple machine. So let's think of a simple machine, a bicycle. A bicycle is the most popular transport system that you analyze in person public transport at school. Every school almost do like a case study on this. So just stick to it, in my opinion. So identify the simple machine there. So it's gears, it's an axle, cable applied as well. Pick that as your simple machine, identify what it is, explain its purpose, social impact. You can say the fact that the bicycle allowed for ease of transportation, cheaper form of transportation. It's also a benefit to say fitness. So many things you can say. Put that into a 4 mark response. Done. Now, with this 4 mark response, you can also stick to just writing dot points. So literally, if I was doing this exam, first dot point will be identifying the simple machine and a relevant example of a transport system. The second dot point is explaining what the simple machine is, and then 2 or 3 dot points to explain some societal impact. So I would say improved fitness, and then you can say like ease of transportation, cheaper, like so many things that you could say. But yeah, that's how you would go about answering this. So if you're like Josephina, you like writing long essays, you can, or like long paragraphs, that is completely fine. Big thing with that though is that sometimes it takes too much time to write it in a paragraph form. Yes, yes, do definitely mention the key technical terms. So that's what I meant by this dot point over here, explaining the simple machine, explain the velocity ratio, the mechanical advantage, efficiency. So you can say, all right, fantastic, Josephine is well ahead. Lever, excellent. That's perfectly what you could say. But yes, I hit answering your. Okay, so what I meant by that is for short answer questions where it's about 2 to 4 marks, dot points is completely fine. NESA is not fixated on paragraph structures or full sentences the entire time. If your natural habit is already to write in full sentences, stick to that. Don't like change your habit. I know for myself, I preferred writing in full sentences every single time, so I just did that the entire time. But dot points is still fine for the short answer questions because engineering markers just care about the answer itself. So have you identified the simple machine? Have you also identified a transport system that relates to the simple machine? Have you explained the simple machine? And then have you identified how it's the specific social impact? That's what they're looking for. So if you can do that in dot points, excellent. Now, when it's a extended response question, for this, no dot points. This is like an essay. So this is where you have your intro, body, and conclusion. And everything needs to be in full sentences, thorough, specific, like it's like an English essay essentially. And NES, I'm not too sure about your trials if they will have this. Each school is different. NESA definitely will put one in the HSC itself. If you go through the past HSC papers, they almost always have at least one 5+ mark question. I know when I did my HSC in 2022, they did have one there. For that question, it's literally like an English essay, intro, body, conclusion. The number of bodies depends on how like long, like how many marks the question is itself. Realistically, the intro is like 1 or 2 sentences. The conclusion is 1 sentence. The body is like 4 or 5. So it's not a long essay, but it still has to be structured like an essay. Perfect. Josephina, I will read your responses later, but thank you so much for adding them in. Wonderful. So we are now done with bus public transport, finally onto aeronautical. Part A, the aircraft above has a mass of 400 tons as is climbing at an angle of attack of 15 degrees. Each engine produces 600 kilonewtons of thrust. The aircraft maintains a constant velocity during climb. In the diagram above, sketch the space diagram by indicating the 4 key forces for flight for this situation. So, very simply, we have our weight going down. That would just be the 400 tons times gravity. So 400 times 1,000 times 10. Put in a suitable unit. So 4,000 kilonewtons. I have drag acting down. That angle is 15 degrees. I have my thrust going up. Now, if the question didn't mention, it is a dual engine aircraft. You can also tell from the diagram. There's one engine on either side. If each engine produces 600 kilonewtons of thrust, I just have 1200 kilonewtons of thrust being applied. And then we have our normal. Now, this diagram, they just expect this because they've just said 4 key forces. When we are analyzing it, of course, the thing we would do is we would break our weight into perpendicular and parallel components. For this part A, you don't need it because it's just asking for the 4 key forces. But for the next part, in terms of finding the drag, that's where we will do it. So we can just take it over to the next part, draw up my quick sketch again. I have my weight, which is 4,000 kilonewtons. I have my drag. I show my thrust, that's 1,200 kilonewtons. We have our drag. We have our normal. Is lift also acceptable instead of... Yeah, you can write lift as well. I think that's probably the more correct one to put in. I'm just too used to incline plane questions. Yep, lift, that's probably the better thing to put in. Thank you for saying that. That is 15 degrees, so we break this down into W cos 15, W sine 15. Now, how would I go about finding my induced drag? What do we do? How would I go about finding my induced drag? When it says induced drag, it's just asking for the drag force. So how do I find what my drag is? Does anyone want to tell me? Go back to your basics of year 11, year 12. So sum of forces perpendicular, sum of forces in parallel. Since this is at constant velocity, that's where we can assume that's like an equilibrium system. So all we say, we look at sum of forces in parallel. Yeah, that's it. So we take up as positive. So thrust is equal to drag plus W sine 15. Therefore, drag is thrust minus W sine 15. That's 12,000 kilonewtons minus 4,000 sine 15. That simply gives us 1,200, 4,000 sine, 164.72 kilonewtons of drag. Yeah, that's exactly it. T minus drag. Wait, sorry. Yeah, so thrust is equal to drag plus W sine theta. Take T minus W divide, and then that's a drag. We don't have to worry about perpendicular in this case because it's not asking for lift. If the question... Okay, next part is where we would do it. Fantastic. Take sum of forces in perpendicular. Lift is equal to W cos 15. That's just 4,000 cos 15. That gives us 3863.7 kilonewtons. My drag from the previous question was 164.72 kilonewtons. Now we can find lift over drag is just 3863.7 over 164.72. That gives us 23.456, or the correct way to say is just say 23.521. Yeah, 23.46, 23.5, depending on what the question is asking, 1.2. Either's fine, but 2:1, that's our lift to drag ratio. You can leave it as this, or you can write in this way. Either's completely fine. They're not too fixated on one or the other. If the question specifically is like, oh, there's 2 dot points here, and then put in your answer, in that case, you would say, okay, 23.5 and then 1. Perfect. D. Identify 2 design features of a modern airfoil that maximize the lift to drag ratio and explain the function of each. This question is slightly more difficult And I specifically wrote it that way because it's asking specifically for the aerofoil, not like the entire wing or like other parts of the aircraft itself. So any like you don't have to give me the full detailed answer. Like, can someone put into the chat or unmute themselves and tell me two or any design features that improve the lift to drag ratio for modern airfoils? This is kind of like a bit off syllabus, and I've purely put this in because they do like asking this. Not exactly. So I'm assuming by that you mean it being directly in front of the airfoil. Is that what you mean? In this, the simplest answer is this is yes, material use is one. For this, you don't have to identify a specific material if you don't know, that's fine. As long as you can explain further on this. By material use, you can say it by reducing skin friction, we improve the lift to drag ratio. Color, not necessarily. Color doesn't really have much of an impact on like aerodynamics. Material use is more so something. So material use is definitely one. Another is this is maybe that's what I mean that this is kind of an off syllabus question and it's kind of more difficult. Wing that it would technically still count. So wing tips or winglets is more so what it's known as. You can technically include that because, as we know, the airfoil of an aircraft is not always the exact same. Yes, fantastic. Thank you. That's what I was looking for. Airfoil shape is what I specifically was looking at. And this is something called cambering. Now, they do not teach you this in the standard Year 12 syllabus. That's what I mean that sometimes they ask questions. Fantastic, Josephina, I'll read that in 1 second. Sometimes NESA, especially trials, it is not even a question that your trial paper will have a wild card of a question that is testing your knowledge on something that further expands on something. Um, that is why, especially for the students who I teach, I always go a bit further in depth on things because NESA and schools love asking like further. Yeah, there is a similar question to this in past HSC papers, exactly. And that's what I mean that most schools wouldn't teach specifically on aerofoils, but that's where cambering comes in. Cambering essentially is something that is done to airfoils where it gets the curved shape in stuff. That's what cambering means. Essentially, it just helps produce greater amounts of lift at lower speeds as well. That's essentially all it does. But yeah, all three of these are perfect. So you can say winglets technically, you can talk about material use, airfoil shape, airfoil designs. That's where cambering comes in. All of them are completely acceptable to include. As long as you can, it's just asking to identify it. But I would still say identify it and write like 3 or 4 words a bit more on expanding it. So that's what I mean, Josephina, your response is fantastic, but for a 2 marker, you don't need to write that much. So that's what I mean that dot points is really good because it's time efficient. If it's a 2 mark question, they're just expecting 2 dot points or like very brief response, get out of it. Like that's all you need to do. So like that response is excellent. I will read through that, but realistically, you don't need to write such a long and thorough response altogether. But yeah, any of these are completely fine as long as you can identify it and then briefly explain it. That's all they really care about. A key thing I tell my students is if it's a 2 mark question or any amount of mark question, always provide one extra. Like there's no harm. In this case, if they're specifically asking for two, just give them two. Sometimes they will deduct marks if you can't read the basic question that's asking for two. If it's just asking to identify features and it's a 2 marker, chuck in a third. Just like in my opinion, it's better to be safe than sorry. Just add in another one, no harm, really done. Perfect. I think we are, yep, almost at the end. All right. Question 26. Describe the basic operational principles of a turbofan engine. Use a labeled sketch to support your answer. This, again, is very specific to the Mod 7 topic. It's asking to explain the basic operational principles of a turbofan engine. So for this, all that they're asking you to do is or how I would personally approach this question is firstly explain all the key components of an aircraft. Obviously, you will draw a sketch for this as well. So we have the fan, the compressor, combustion chamber, turbine, nozzle. Those are the key components of our turbofan engine. So that's the first thing you can kind of talk about is explain the main components or basic operational principles of a turbofan engine. Another thing I would strongly urge you include for a turbofan engine is explain what the overall difference between a turbofan and a turbojet engine is. It's the fact that a turbofan looks something like this, where there's a separate duct on the outside, whereas a turbojet is literally just it's just the internal version of the turbofan. And the difference between this, as we know, is in a turbofan, not all of the air goes into the engine. We have a lot of bypass air that is done on purpose purely to quiet down the engine. So that's why a turbofan engine is significantly quieter than a turbojet engine, is because of the fact that the air is kind of suppressing the sound. So that's something else you can talk about in this response. 3 marker, so 2 marks for the response, 1 mark for the fan. I think realistically this is more of a 4 marker. I kind of just cut down on the marks. But yeah, that's also an air efficiency. Yes, that's another thing. It's both on efficiency, but more so the main principle also is to quiet down the engine. For commercial aircrafts, the biggest thing we care about is obviously efficiency of the aircraft itself, but also making sure it is comfortable and suitable for commercial people to fly in. For a turbojet engine, it's in your fighter jets. For there, we have military operants who are flying the aircraft. They don't really care about sound because they're wearing like ear protection and whatnot. If you're flying on it, if you're catching a flight from here to Melbourne, you're not going to be wearing like earmuffs like going onto the plane. So that's why sound is a big thing. We also want to make sure is addressed. But yeah, efficiency is also a key thing that it does. Perfect. Final question is part B. This is looking more so at turbojets aren't entirely use these as either. They still do use lower bypass turbofans. The older aircrafts do still use turbojets though. For example, if you're looking at your SR-71s, they have those two big turbojet aircrafts on either side. But yeah, like with design, each like aircraft is being designed in some either way. We now even go to scramjets and ramjets for certain aircrafts as well. But yeah, you're completely right. Perfect. Final question we are now looking at. Describe solution heat treatment and artificial age hardening of 7075 aluminum alloy. Name the 3 stages and explain how they increase yield strength. Now, simply all that you would do for this question, you get 1 mark in identifying the 3 stages. I'll like very simply, first stage is the solution heat treatment stage. Fantastic. Second is the cooling, so quench, and the final is the aging. As long as you can identify these 3 key stages and then build up on it, no issues in getting your full 3 marks for that question. Now, Josephina, I will wait for your response to part B, and I will read the rest of your responses. Otherwise, in terms of the exam, that is it. We pretty much finished exactly at 90 minutes, which is fantastic. I will now open up the floor to all of you. You guys can unmute, like turn your cameras on if you like, or in the chat, ask any questions that you might have about the exam, any other specific questions itself. I know in the forum, some of you had some questions. Let me pull that up. Is it any good way to apply extension 2 and uni level maths to save a large chunk of time? Not really. I think the maths in engineering studies overall is quite basic as it is. Like your basic trig, basic algebra. Yes, I will be uploading this recording online on YouTube, and then I'll be sending an email out to all of you with the link to the video itself. I'll also be sharing the solutions, both handwritten and the ones that I have already created to all of you as well. So you guys will have this recording and solutions both. So like no issues there whatsoever. But good question. Thank you. Any resources that teach content from year 11 to 12, everything included and for free. Um, Not that I know of, from year 11 to year 12 for free. If anything, use AI. A big thing that you guys have as an advantage as compared to when I was doing my HSCs, you guys have AI and you can learn a lot with AI if you ask it the correct prompts and whatnot. So if you want resources that teach you the entire content from year 11 to year 12 for free, use AI. I myself Great question. It was very beneficial. All of first year uni for engineering is engineering studies, essentially. It's first year engineering at university is engineering studies entirely. You learn about truss analysis, you learn about bending stress, like shear force, bending moment diagrams. Even as a fourth year, I'm learning stuff like this because I study aerospace engineering. I'm now looking at aerodynamics and all of that in a lot of detail. So engineering studies, I'm very grateful for having done that in my HSC because it's very useful for my degree when I'm doing it right now. Is it a science ready equivalent for engineering studies that you know of? What do you mean by that? My dad says that engineering studies is really good at preparing one for first year university, so I'm glad to hear. Yeah, exactly. It is very beneficial for first year, even second, third, fourth. Like even now as a fourth year, I'm still grateful that I did engineering studies because it taught me all the basics that I needed. More so, even like the stuff that you learn about historical and societal influence, that carries on into uni as well. So like I'm very glad that I did do it. Fantastic. Josephina, I will read all of your responses and I'll add them into the solutions just so everyone else has access to it as well. Science Ready is a website that posts in-depth notes and videos on HSC chemistry and physics. I don't, yeah, so that is a great question that you have raised, Mahit. Um, I personally do not know of any place that has like I know of Science Ready for HSC chemistry and physics. I don't know of any for engineering studies myself. One thing is I myself am trying to build my own website for like notes for Science Ready. It's still in the process of being built. Me myself, engineering studies is my favorite subject to teach. I've been teaching it for over 4 years now, and I like kind of know it like by the back of my hand because I've taught it year after year for both year 11 and year 12. Um, yeah. So in terms of online notes itself, practice materials, excellent question. So I myself am creating a lot of questions and booklets that I'm like working on. So if you guys are interested, you have my email, you have my number, or I don't know if you have my number, but you have the socials for etc. Tutoring, so you guys can reach out there. And I can definitely share any content or materials that I do have with all of you guys. As a student, like a few of my students are in this webinar today, they have access to it all for free as it is. Excess materials for like non-students that can be discussed, but just message me one-on-one and I can address that. Um, yeah, so I didn't include telecommunications in this exam because not every school goes through telecommunications by the time it's their trials. A lot do it after, so that's why it doesn't get to be in the trial itself. If anything, if it is included, it's just the first topic of historical developments, environmental impact, society stuff, which is not really that difficult. It's just going to be a short answer question that is going to be asked. But yeah, Josephina's added in a link. Yeah, THSC does have online resources and papers. Not that many. THSC is like old and quite limited. I know it does have my no Sydney Tech's trial paper. Yeah, yeah, six papers. It's not like the resources for engineering studies on THSC is very limited. Um, that's why I've started creating my own. Um, and I can quickly share my screen and show you guys just a glimpse of, or I can just share a screenshot of this. Just bear with me. But keep asking the questions. Yeah, six papers. Yeah, that is right. Yeah, so as I said, I am currently in the process of creating Accelerate Plus, which is going to be like a platform specifically for engineering studies, but other subjects slowly, but engineering studies is kind of where my forte is at the moment. So currently I have already created Let me add a screenshot. So yep, I'm just adding into the Zoom chat so you guys can see there. So currently I've already created booklets for each of the year 12 and year 11 modules. I also have booklets as overall exams, so practice exams on each module as well. It's purely designed because, as you guys know, there is a limited amount of resources online for questions and notes for engineering studies. It's overall very limited. And I kind of want to help address that by creating questions myself, because obviously I have done engineering studies myself and I have taught it for over 4 years. So I know what type of questions to ask and what type of questions actually come up in trial papers and HSCs. So that's what I'm working on. If you guys are interested in that, as I said, you guys have my contacts. You guys can ask me at any time and I can share it over. Perfect. Keep asking. My notes. So when I teach, it's very free flow. Like I write it like as I did today. I'm also working on creating separate note booklets that are purely like theory based. Mechanics, as for notes for mechanics, is not really something you need. It's more so you will learn by just doing more practice questions. For the theory, notes are useful there. Whenever you are structuring your own notes or how I structure mine, please use the syllabus. Engineering studies' syllabus is written exactly like a checklist. So literally when you are writing your notes, you're revising for trials, for HSC, literally go down the syllabus as a checklist and tick it off as you go. It is written perfectly well, and you can structure your notes exactly to the syllabus, and you will have everything covered essentially. But yeah, fantastic question. I think in terms of the forum, no other questions there. If you guys any other questions, unmute yourself, ask in the Zoom chat. Here to answer any questions you guys might have. Sketching questions. I myself never teach sketching questions because it's kind of difficult to do it online. If anything, there are a lot of online resources or videos of people doing sketching questions. They're done by people in university, but it's the exact same skills. Like there's no difference between sketching in uni versus sketching in engineering studies. That's what I mean, that there's an overlap. So I would recommend just watching online videos where people are kind of showing the sketching being done using like protractors and compasses. Is there any methods, techniques you would recommend for just general study or exam prep? Great question. Spam out as many questions as you can, especially for those who are in year 12. Your trials are coming up in about a month and a half time. The more questions you can do, the better. Purely because I think, especially for mechanics, in my opinion, is always the harder topic than theory. In theory, you can always waffle your way around and get some marks. Mechanics is like where the maths component is. So more questions you can do there, the better. There's a lot of like it's difficult to find online resources, but even doing the past HSC papers is good preparation for trial prep. For you for year 11, there's not much. I think THSC might have something for year 11. Otherwise, reach out to me. I do have some material stuff for year 11. AS 1100 being in the syllabus makes technical drawing very difficult to learn to any reason. Yeah. One thing I will say, the biggest difference between engineering studies in high school and university, you will almost never do hand drawings in university ever again. So one thing you guys learn is CAD, CAM, but you just learn about the benefits of it. When you go into university, you start actually doing CAD drawings where you're doing it online on a software like SolidWorks, InDesign, Fusion 360, CADIA. There's so many different softwares out there, but you will never do hand drawings again in university itself. Unless you're doing like architecture, you might do it there. Yes, yes and no. HSC, no. Trials, again, the difference between trials and HSC, trials is dependent on your school. Each school is different. That's why they may add it in. In terms of the HSC, no, not that I've seen, not much on auxiliary view drawings. Yes, so resources can be bought separately as well. That's what I meant that I give it for free to all my students. But if you do not want to get tutored and just want the resources, that can be bought separately as well. So reach out to me. I can share the details there. Focus on you topics you would focus on or you find most tested difficult questions. Truss analysis, please definitely do that. Bending, shear force, do that. One thing I would say is when we did our bending moment question, it was just a simply supported beam. How NASA can make this more difficult is by making a UDL, so uniformly distributed load, or even NDL, so non-uniformly distributed load. Work on that. Cantilevers, again, the likelihood is kind of very like it's not that high, but still do prepare for that because for a cantilevered system, again, it's simply just where this is gone. I now have a moment being applied because it is a cantilevered system. So practice on that, learn how to do cantilevered systems. They could ask that. Do you recommend using an iPad for note taking and studying? When I was doing my HSC, I didn't have an iPad. I would like handwrite or type things up. If you do have an iPad, definitely do use it for note taking and studying. Um, there's no need to print stuff. If you can download a copy, chuck it onto your iPad, do it there. Again, as I've said, for engineering studies, the main way to study for it is for mechanics, practice questions on repeat, just constantly keep doing it. Um, for the theory, just read notes. So for that case, you can type it up. I hear John Rockford's textbook is bad resources. Yeah, it's not. I've looked at the textbook for that. It's not great in my opinion. If anything, I would say there is one person called Schlenker. I will add this. Copeland, I have gone through it. I think it's better than the Rochford one. Um, I will add this into the Zoom chat. Um, there's this person called, I don't know the person's first name, but their last name is Schlenker. They have two textbooks, one for year 11, one for year 12. Um, and it's purely on mechanics questions. So it goes through all of the mechanics questions and mechanics topics. So simple machines, concurrent force questions, truss analysis, work, energy, power, even electricity. So like series, parallel circuits. It goes through everything. So that, if there's any textbook I would say you guys should look at, it's the Schlenker one. I have a copy of it. You can also find free versions online. Um, there's paid versions as well, but there's always like alternative. Just find a free version online. I wouldn't recommend buying it. But it's a great textbook to use. For year 11 as well, there is a version for year 11 as well. So if you're in year 11 preparing for prelims and you want to do mechanics questions, literally just go through that. It's very simply written, but it's a fantastic textbook altogether. But yeah, great question. Any other questions? Feel free to ask. I'm currently at UNSW, so I haven't finished my degree. I'm currently at UNSW, and I went to Sydney Boys as my high school. So I did my HSC in 2022. I went to Sydney Boys, and then I'm currently at UNSW. I finished my degree next year, so I'm currently in the final year. So I finished like beginning of next year. Did you guys enjoy this webinar? I would also love to hear your feedback if you guys enjoyed it. If you would like to see something similar to this, I do plan on doing at least two or three more of this. Consider tutoring for year 11, 12, etc. Price ranges are all on the website. Usually for year 11, 12, it's $80 an hour, and then for year 7 to 10, it's 60. We have a lot of discounts that always go around. The biggest one right now is just to follow our social media pages. Obviously, we're trying to grow our social media presence. So if you follow our social media pages, we give you $10 off. Yep, lovely. I will probably be doing another one of this closer to the HSC itself. So that one, same setup. The only difference will be there will be telecommunications in the exam itself, and it will probably be a 3 hour webinar. So, or like probably a bit longer, maybe 2 hours for the exam and then half an hour for Q&A. It will be because it's a longer exam, and it will cover telecommunications in there as well. And for year 11, I'm going to do a webinar for year 11 as well for prelims that are happening pretty soon. So look out for that. Join for that one as well. But yeah, any other questions? I love that you guys enjoyed this. The recording of this will also be sent out, so if any of you didn't hear. Yeah, fantastic. Yeah, so you're well prepared for your year 12 now. You're still in year 11, so I'm assuming a lot of the content would have been like a bit new to you, but it's good that you did watch it and you were here. And it's kind of, as you said, prepared you well for year 12. Not entirely. You don't need to go through year 11 content all over again. There is some overlap, like between the modules. The more so, the theory is not something you need to worry about because I kind of go through it again in detail. The mechanics is something that you do definitely need to know from year 11 because in year 11 you learn about friction, you learn about like stress, strain, you learn about like concurrent force questions. So that is kind of the basics from year 11 they expect you to learn again. In terms of theory, they kind of teach you that all over again, or at least I do to my students. It will be the exact same way. So I'll be posting social media links online. It will be on my website as well. So if you follow us on our social media page, the Instagram page for Accelerated Tutoring, um, very soon, probably in like a month's time, the webinar for year 11, so the prelim webinar will be. And then you can just, same thing, Google Forum, fill it out, you'll get an invite, and then same exact setup. For scaling, I personally don't agree with that. I think it's based year on year. Um, it's obviously doesn't scale as well as obviously your maths and your like chem phys, because obviously they're significantly harder. Scaling, in my opinion, overall is quite good for engineering studies, but it can take a big hit if the exam is significantly easier. I think 2023 or maybe 2024, the scaling wasn't that great because of the fact that it was an easier exam as compared to previous years. So the scaling did kind of fall off altogether. Yeah, so Conquer, I am on Conquer's Discord as well, so I put that there. But otherwise for the prelim one, I would recommend just following us on our Instagram page, and then probably in 4 or 5 weeks' time, I'll put out like a post about that, and then you can same thing, Google Forum, fill it out, join the prelim one, and then the same thing for the HSC one that I'll do later as well. It will be the exact same process that you guys can follow our social media pages, and when it does come out, fill out a Google form, you guys will get the invite, and then same exact process, we'll be going through an exam together. Great question. I would say for revising theory, like you don't have to retype your notes. Read through your notes like 1 or 2 times. Flashcards, like not really. Spamming out questions, in my opinion, is the best way. The more practice you get of actually reading short answer questions and writing it out, the better you will be. The biggest thing with theory is students often neglect writing out their solutions. Like if you see Josephina's solutions, they're so in depth and well written. You want to practice doing that. The more practice you have of doing that, the better it will be. A-Town Notes is pretty good. They often have quite a lot of good resources there, actually. So not a bad place to get some like notes online. I know when I was in my HSC, I used like A-Town Notes to help like refine my own notes. Great question. Double or single degree, like both have their pros and cons. When I was doing when I picked my degree in first place, I was first doing a double degree with computer science. I then dropped it because coding was not really something I was interested in. It was more something my parents told me to do. Aerospace was always something I wanted to do when I was a kid. Double degree, the benefit of it with engineering, it kind of opens up more doors. So a lot of students do like engineering with commerce, engineering with maths, engineering with computer science. It's just a benefit because it gets you like opens another door essentially. I did not do D&T in year 12. I did it like as an elective in like year 9 and year 10. You don't really need D&T in engineering studies because you're not like it's a good skill to have, but you kind of learn all of the D&T stuff in uni as it is. But yeah, if you have any questions about degrees and stuff, feel free to ask that as well. But yeah, do you think? Personally, yes. I guess there's a bit of bias there, but I do think yes. When I was in high school, I did a project with a professor at UCID in the aerospace. There was an aeronautical engineering professor who I did a 2 week work experience project with. And I think with UCID, the engineering department is very outdated. It's not bad, I would say. UCID's engineering department is relatively still quite good, and they're growing a lot. But I think UNSW just tops it, in my opinion, by a significant amount. And that's why it's like the number one uni now altogether. But I think the engineering department at UNSW is like top tier. Like I don't think there's any other university in New South Wales that can come close to it. You don't need a portfolio for early entry. I think usually they just look at your grades and just get you in. Do you need no, they don't guarantee. That's the one downside I would say between UNSW and USyd or like other universities. Other universities kind of help you a bit more in terms of getting work experience or like internships. UNSW, they kind of expect you to do it yourself or they provide some support. So that's kind of the downside. In terms of support from like staff and stuff, it's kind of not as well as compared to other universities. But in terms of the curriculum, the opportunities in terms of student projects, like societies to join, it's far greater at UNSW. Like there's a rocketry team, we have like an F1 team, we have a Skylabs, which is like you create an aircraft. There's SunSwift, which where you create like a solar race car. We have a high altitude, yeah, Redback is the F1 team. So there's so many like projects to be a part of. And like say if we have an atomic fusion team. So if you're into nuclear engineering, you can join that. So many projects at UNSW. Adam Croft, exactly. Yeah, Josephine as well. But yeah, Adam Croft. We have the rocketry team, as I said. BlueSat, which is focused on like creating a Mars rover, and then also looking at high altitude balloon testing. RAMSOC as well. RAMSOC's a society, and they also do projects on the other side. That's another thing I would say. A reason why I picked UNSW as compared to other universities is kind of the society and social aspect. Social life at UNSW is probably the best because they have so many societies and events that happen all throughout the year. And especially as first years, you guys will have so much fun as a student at UNSW. I'm sure at other universities as well, but I know some of my friends from other unis say that, oh, I wish I went to UNSW because you guys just have a better social presence. Great question. A lot of it is online, I would say. In my first year, I was more excited to go in person, watch lectures in person, and whatnot. But now as a fourth year, I'm like sick of it going to lecture. Everything's recorded. For tutorials and other stuff, they are in person, like it's mandatory. But for lectures, all lectures are recorded. You get the recording afterwards, so you can watch it in your own free time. But otherwise, I would say as a first year, spending more time on campus is better because you want to make the most out of your first year of university and actually enjoy the university experience. But when like as you progress into uni, you kind of get sick of it after a while. Not 5 days a week, so that's a great question. It's not like high school where you have to go every single day. It's very much dependent on how you set your timetable, but usually it's like 2 to 3 days on average. Sometimes it can be more, it can be less, depending on your degree. I don't know anyone who passed every engineering semester. Do you mean like didn't fail? Um, it's very common for people to not fail courses. Myself, I have failed engineering courses for computer science. That's why I dropped it. But like I know people that smash everything. Like it depends on how much work you put in. Like when I was in my first year, I was more like focused on just having fun, making the most of my social experience. That's why I wasn't like studying as much. But as long as you're on top of things, you'll never have a struggle of like failing a course. I did in my first year. I did. I was playing social OzTag. But then now I'm in my final year. I'm doing my thesis. So I don't have the time. But yeah, social sports is a big thing at most unis. UNSW has it. You said all universities have like social sport that you can be a part of. But yeah, it is 12. So if you guys don't have any questions, you are free to go. If you do have questions, feel free to ask. As I said, I will be sending out a recording of this to all of you. So you guys can always watch the recording, go through the solutions yourself. A lot of international students at UNSW, but all unis really. It varies depending on like ethnicities, depending on the university itself. Yeah, so glad you guys enjoyed it. Thank you so much. But you got any other questions, feel free to ask. Otherwise, you guys are more than welcome to leave. Um, like definitely do follow our social media pages because there'll be other webinars happening very soon. Thank you so much. I'm glad that at least someone picked up on that. Thank you so much. Wonderful.